Hi, I'm Mr. Kangas, and today we're going to talk about Chapter 11, Section 5, and we're going to be talking specifically today about the surface area formula for a cone. This is one of the harder surface area formulas to comprehend because it has a very complicated piece to find the area of. Now, surface area simply asks us to find the area of every surface on a figure and then add all those areas up. And so if you take a look at a cone has two surfaces. It has its base, which is a circle, and then it has the lateral area, which when unraveled, if I made a slit down here, down the slant height, and unraveled it, it would actually turn into a fraction of a circle. So I might get like 3/4 of a circle, or 2/3 of a circle, or 1/2 of a circle. It all depends on the cone you're dealing with. Okay? So there are two surfaces you need to find the area of: the base, which is always a circle, and the lateral area, which unravels into a fraction of a circle. And so the first part of the formula is pretty simple to understand. The base is a circle, and so the first part of the surface area formula is just simply pi r squared. Okay. So there's the area of the first surface out of the two surfaces, which is the base, or that circle right there. Okay. The second piece to the formula is pi times radius times slant height, and this is where things get a little confusing. Most people are not going to be able to look at pi times radius times slant height and figure out that, oh yeah, that obviously gets me the area, the lateral area of my cone. And a big part of the reason why it's almost impossible to look at the surface area formula and figure out how this gets me the area of the lateral area, the big reason why you can't do that is because this is actually a shortcut. Okay? In order to find the lateral area of this cone, there's actually a much bigger formula, which is 2 pi r over 2 pi l times pi l squared over 1. Okay? This is actually the lateral area formula for a cone, and I will explain why this works in the next video and how it turns into this. But essentially, through reducing and cross-canceling, you get pi rl out of this bigger, more sensible formula. Now, to most of us, we're looking at this bigger one and we're going, how does that make more sense? Well, after you watch the next video and I explain where all the different pieces of this come from, it will make more sense. Whereas this is a shortcut and there's almost no way for you to just look at that and go, okay, obviously that works. With enough knowledge of your basic formulas of a circle and enough knowledge of the lateral area, you can look at this and make sense of it. So basically what happens to go from the bigger formula down to pi r l, your 2's are going to cancel out, your pi's are going to cancel out, and then you cross cancel your l's. So this l's gone, and here we have l times l, so one of those l's is gone, and what we have left is radius times pi times l. And remember, l is slant height, just in case you forgot that. Slant height would be that diagonal distance traveling down the cone. Okay, and so r times pi times l gets you pi r l. Remember, when you multiply these three things together, you can put them in any order. We typically write pi r l. I could have wrote r times pi times l. It's the same thing. And on bottom, we have 1 times 1. And so we get pi r l over 1, or in other words, just pi r l. But in the next video, I will explain to you why pi r l gets you the lateral area of this cone. Make sure you write down this formula. Make sure you're taking notes on all of this, because this is important information for you to know. Okay? So tune in for the next video for the explanation as to why pi r l works for the lateral area. I'm not going to explain pi r squared. I've done the area of a circle in the previous video. And that would be back in chapter 10.